Now HyFem is capable of doing linear, static, transient and modal analysis in structure and linear harmonic analysis in acoustic. We do analysis in Fortran and we use MATLAB GUI interface for pre-processing. Some basic geometries can be modeled and meshed in HyFem. In 2D, these are the primitive geometries available. For each geometry, you have to select the element to be used for FEM analysis. For each geometry, you have to specify few parameters. For Cartesian mesh, you have to specify number of element in x and y direction. Then the coordinate of bottom left corner and top right corner. In user document, some 2D geometries are described with associated parameters. There are few axisymmetric geometries and also some 3D geometries. Any two basic geometries can be assembled in HyFem. For that, you have to add the second part. Now, our assembly require the origin need to be here. So you have to shift the origin by 3 1. Furthermore, this is the common surface between two mesh. Then you have to collapse node on this common surface. You have to select the required face. For some assembly, you may require to collapse node of some parts of the surface. For that, you have to use part. Here we will use all. Then you have to assemble the parts. Now, suppose you want to shift the origin from here to here. You can modify the assembly using modify parts. Here we want to modify the parts 2 and we want to shift the origin. You can modify the mesh also. One important thing one should notice that these two mesh are compatible to each other. Assembly requires that. More than two parts can be assembled in HyFem. In HyFem, there is another one feature pattern assembly. If there is translational or rotational repetition of a pattern that can be modeled in HyFem. For example, in turbine blade we have rotational repetition. Let us consider a hypothetical scenario where this pattern is repeated 3 times and this point in the next pattern is located here. Then the distance between two successive pattern is 7 2. Furthermore, the nodes on this region need to be collapsed on each successive pattern. Here we have to select part. This is increment. Now let's see the assembly. There may be situation where HyFem basic geometries and assembly features are not capable to model some geometry. Then one can model that complex geometry in available more general preprocessor like Gambit and Abacus. He has to follow the guidelines mentioned in the user document. Then those mesh can be imported in HyFem. Some previously generated HyFem mesh can also be imported. Furthermore, if someone model and mesh something in HyFem, then that mesh can be exported as Abacus format and can be used for further analysis in Abacus. This is all about the geometry features in HyFem.